Three, two, one.
This is StarTalk.
Junior.
To start, I just want to ask, what is most fascinating about your work?
Boy, good question. So I guess what I find most fascinating about my work is that when I started in this field 40 years ago now, um, we sort of thought we knew the size and scale of the universe. But it turns out that we only really know about 4% of what makes up the universe. The other 96% is dark matter and dark energy. When I started, we kind of knew about dark matter, but we had no clue about dark energy. And that's 70% of the universe. So we sort of went from thinking we knew about at least half or maybe all of the stuff that made up the universe. And got from that to, no, it's only 4%. And of that 4% that we understand, that's regular matter, everything that makes up you and me and all the stars and planets. Of that 4%, half of it we can't find. So we really only know 2%. So there's a lot of work to be done still to figure out what's going on.
Do you think you can go for it. Do you think in the near future we would ever have the possibility of getting to all the dark matter and exploring what it really means?
So the dark matter is probably easier than the dark energy. And it's possible that it's a subatomic particle that we haven't yet detected. There are some people who think it's just thousands and thousands of rogue planets floating out there. So there's a chance if it is an elementary particle that we might actually discover it. And the rogue planets, I don't know. I mean, we found some. I mean, those are really hard to find, right? These are planets that are not orbiting a star. They're just floating out in space on their own. But we found some through a strong gravitational lens. So yeah, we might be, and even dark energy. So have you heard of the Hubble tension? Is that a word that rings a bell, you guys?
Oh, no, I haven't heard of it. Have you?
No. So the Hubble tension is a relatively new thing. So the Hubble Space Telescope was built to measure the Hubble constant, amongst other things. So that's the rate at which the universe expands. And again, I go back to when I started in astronomy. When I started in astronomy, we knew it was somewhere between 50 and 100 in the units of kilometers per second per kiloparsec. Somewhere between 50 and 100. So now Hubble telescope has measured it really, really accurately, and it's 74 plus or minus 1. So Hubble measured that. So then the Cosmic Microwave Background Surveys, they also measure it, and they also measure it really accurately, and they get 62 plus or minus 1, and that doesn't match 74, and it's the same physical parameter they're both measuring. The Cosmic Microwave Background people, they measure when the universe is very young. Hubble measures it more like now. So something is wrong, and that thing that is wrong is called the Hubble tension, and it hints that we don't understand how the universe works. And maybe we'll figure that out. I mean, the fact that we know there's a problem is the first step, right? You don't know there's a problem, you go along your merry way thinking everything is fine. But we do know there's a problem now. And there's a telescope launching in about 2 years called the Nancy Grace Roman Telescope. And it's kind of like the Hubble, but it surveys the sky thousands of times faster than Hubble does. So it may shed some light on this problem. Yeah, maybe. I don't know. I mean, I don't know. It's a problem that only come to light, I would say, in the last 5 to 10 years.
Wow, that's incredible. So you've done a lot of work on black holes. And what do you think that we are living inside of a singularity or simulation?
So that's a great question. My future daughter-in-law sent me that question a few months ago, and she sent me a podcast that asked that question, and it's really cool. Maybe I can find it and send it to you guys. So it was an interview with an astronomer who studies black holes. He said, well, there's a really simple equation to tell you how big the event horizon is for a black hole. It just depends upon the mass of the black hole and then how small it is. Let me go back. There's a simple equation that tells you when a black hole will form. If you get too much mass and too small an area, it collapses to form a black hole. And the too much and the too small, you can put numbers to it. So if you put those numbers in as the mass of the universe that we understand right now and the size of the universe that we understand right now, it comes out that we are in a black hole. That doesn't mean we are, okay? But the numbers do work out that way, that if you just naively apply them to the universe, you get the answer. Oh, yeah, you're inside one. I don't know if it really means that. There is a finite size to the universe, right? It's only 13.5 billion years old, and it's been expanding at an ever increasing expansion rate because dark energy is pushing everything apart faster and faster. But nonetheless, it has a finite velocity and a finite time. So it has a finite size. So the universe has a finite size. So the edge of the universe, I mean, that you could call that an event horizon, right? I mean,
Wow.
that's kind of what an event horizon is.
So,
So
so could that mean that every black hole has its own universe in it?
maybe. The singularity right at the center of the black hole, the fact that it's a singularity means we really don't understand anything that happens inside of that space. We have zero clue. So pretty much anything you say is possible because we have zero clue what happens inside that singularity.
Incredible.
So
One of my
okay.
great friends, colleagues who also studied black holes, a fabulous astronomer who's passed away now, by the name of Jeff McClintock, he always said, a Mack truck could just appear and drive out of the center of that thing because you just can't say what's going to happen.
So potentially we could also have a flat Earth. Potentially
A flat Earth?
in one of the black holes. Potentially we could have a flat Earth.
Potentially. But I have to say, my favorite T-shirt that I wear, it's a picture of the Earth. It's a big round picture of the Earth, and then it has the NASA slash through it, and it says "not flat." We checked.
That's hilarious. So we're kind of coming to an end. We don't want to take up too much of your time, but can I just ask you to explain this in under 30 seconds, as if you were talking to like an astrophysicist?
Explain what?
Just like black holes and singularity, and the possibilities.
Oh, well, if I was inside a singularity, I could probably do that, but I'm not. So I probably can't do it in 30 seconds. I will say that if I have the numbers right, the size of a black hole of the singularity is 10 to the minus 34 meters. So it's really tiny. It's way smaller than the smallest subatomic particle. And the density is infinity because that's what it means, a singularity, right? It means the numbers don't make it. So it's a little point where the density is. We know they exist, right? We know there's one pretty much at the center of every galaxy. There's one at the center of our galaxy. It's in constellation Sagittarius. I'm a Sagittarian. Yay. So the center of the galaxy is in my constellation. And there's a black hole there. And yeah, there's one in then our nearest neighbor, the Andromeda galaxy, all except for the really, really tiny. It's like the Magellanic Clouds, right? They are galaxies, but they're dwarf galaxies. They probably don't have black holes in their center. They're just
Would the
there
dwarf
you go.
galaxies like still possess a star?
Yeah, dwarf galaxies are just small groups of stars. It's just a small galaxy. So the Magellanic Clouds that you can see from the southern hemisphere, right, the large and the small Magellanic Clouds, they're little dwarf galaxies. They've probably gone through the center of the Milky Way and gone back out. They're in orbit around the Milky Way. They may have actually dove in and come back out the other side. You can see a stream of stars, very faint, going from the Milky Way out to the Magellanic Clouds.
Wow. Can I just ask you one more thing?
Sure.
What is one thing? Is there anything in space that like keeps you up at night? That's such a mystery.
Jeez. No, there's nothing that worries me. Even the asteroid that has a 1% chance of hitting us in like a decade from now, it's probably not going to hit us. And if it did, it'll probably land in the ocean and, probably won't cause any real damage. I wait for the next exoplanet we find. We're finding huge numbers of them. And, want to see the first one what's even better? Europa Clipper just launched a couple of months ago.
Oh yeah.
So it's going to Europa and it's going to orbit it. Europa has an ocean. It might have a sheet of ice. Well, it does. It has a sheet of ice at the top that's a couple miles thick. Then it has an ocean that's maybe 50 miles deep. And then at the bottom, it probably has hot volcanoes, mid-Atlantic trenches. So there's probably life in there. and it's pretty close by, and we're going to orbit it and maybe see if there might be life. But eventually, we're going to find life on one of the moons of Jupiter or Saturn. You will live to see it. Or real life, that might even be like squids and fishes and things in those oceans. Who knows? Or maybe it's just, but it could be complex life.
That's incredible.
I'm thinking like Ray Bradbury books come to life.
Yeah, definitely. Like the improbability thing from Douglas Adams.
Mm-hmm.
Talking Hitchhiker's Guide to the Galaxy.
Yeah.
Yeah, the infinite improbability. Yep, that was pretty good. Just a really hot cup of tea.
Thank you so much for your time
Yeah,
again.
thank you for having me, and nice to meet both of you.
Good luck.